Okay, so let's consider this system of equations. So basically we have two equations, right? And we want to compute values of k so that the system of equations have no solution, right? So basically this is this equation 1, equation 2. Basically these are lines, right? So equations of lines. So this equation 1 is a line, and also more importantly, I can create that slope intercept form, because that way I can get a better idea about this line. So basically I'm trying to create y equals mx plus b form, right? Because here we are not trying to solve this system, right? We want to determine number of solutions. So I'm going to subject y. Let me move 3x to the other side. Then we can divide both sides by 2 to create that form. Now that is basically y equals 3 over 2x minus 8 over 2. So since we need a plus sign here between mx and b, 3 over 2x minus 8 over 2 minus 4, I can express that minus 4 as plus minus 4, because I need that plus sign. That's why I simplified like this. More importantly, now we can compute the slope and the y-intercept of that line. In other words, we can draw this line actually. But why do we need this form? Right? I'll answer that. So let's apply that same idea, same concept for this line. So here, don't worry about k. K is just a constant, not a variable. Then we can divide both sides by 3. Very similar. I'm going to divide both terms separately by 3 because I can't keep that common denominator, because by keeping that common denominator, I won't be able to create y equals mx plus b 4. That's why. So k over 3x plus 15 over 3, that's 5. Now that's line 2. Now this is, again, I can compare this equation with y equals mx plus b. Now, basically, number of solutions or solving this system, what's the meaning of that? So the graphical meaning is quite interesting. It's basically number of intersection points. Number of intersection points of these two lines, right? So if we are talking about a case like this, then we have one solution. For a case like this, whenever we have two parallel lines, no solutions, or sometimes lines coincide top of each other, then infinitely many solutions. But in this case, to get no solutions, I think we need a scenario like this, two parallel lines. So to get two parallel lines, slopes of two lines should equal. Because when our slopes equal, basically we are talking about the same direction, hence those lines parallel. So number of intersection points, that's what we need. So we can compare these two. Let me use a different color. Yeah, this equation and this equation. Basically, I'm trying to compute slopes. Right? By comparing slope intercept form and this equation, I can easily compute the slope of line 2, let's say M2, which is k over 3. And slope of line 1, m1, that is 3 over 2. Now we can compare these two because that's the way to determine number of intersection points. Because if m1 equals to m2, what will happen? Then we will have two parallel lines. Basically, that's what we need. m1 equals to m2. Then we are talking about a case like this. So basically no solutions. Why? Because no intersection points. That's why. Right? So 3 over 2 equal to k over 3. Then basically you can solve this one for k. We can multiply both sides by 3. So k equals to 9 over 2. So what's the meaning of that? For that k value, these two lines parallel. Hence no solutions. Right. So what's the requirement to get one solution or infinitely many solutions? We can discuss about that with different problems, right? So slopes are quite important. Comparing slopes is the way to go in these problems. Right? So let's try the second problem. Right, quite similar, but slightly different because of this one solution. Right? So what's the graphical representation of that? So basically we are talking about a situation like this. One intersection point like this. That's the solution. So to have such a situation, to get such a graph, two lines like this, what do we need? Right? First of all, there can't be a situation like this. Two parallel lines, because for two parallel lines don't get intersection points. So definitely, what's the meaning of that? Slopes should not equal, because whenever slopes equal to each other, you are going to get parallel lines. That's not what we need in this occasion. Basically, slopes should not be equal. M1 should not be equals to M2. Yeah. So to compute slopes, we can create y equals mx plus b form for both lines. That's very easy. Then we can compare. So create, you can move 4x to the other side, then divide both sides by 5. Divide both terms separately, plus minus 1. Okay, initially minus 1 over 5. Then of course, we can create a plus sign because then we can compare, because this is the slope intercept form. Now basically slope equals to 4 over 5 for the first line. Let me use M1. Then for the second line, same idea. I'm going to move Lx to the other side, minus Lx plus 40. Divide both sides by 10. Same concept. Divide both terms separately by 10. 40 over 10, that is 4. So that's the desired form, right? Y equals mx plus c or mx plus b. Some people use b, that's fine. So the slope of the second line is minus L over 10. Now, and also we can talk about y-intercepts. The y-intercept of the first line is -1/5. And for the second line, 4. Now, for example, to get no solutions, we need parallel lines. Hence, M1 should be equals to M2. That's for no solutions. Right? So let's talk about that. For no solutions, we need parallel lines. Hence, M1 should be equals to M2. That's the requirement for parallel lines for no solutions, which means no intersection points. So 4/5 equals to -L/10. Multiply both sides by 10. Even better, if we multiply both sides by -10, because I want to remove that minus sign in front of L. Right? Here 10 and 10 will cancel. This is actually -1. I did divide both terms by 10. Then minus L into -1, that is plus L. And also for the left-hand side, 5 and -10, 1 minus 2, that is -8. So L equals -8, which means for that value, these two lines parallel. So you won't be able to solve that system for that L value. Why? Because no intersection points. Then for one solution, now that's a bit tricky actually. For one solution, we need a situation like this. For that, I think slopes should not equal. I think that's the only requirement. Yeah. So basically, M1 should not equals to M2, which means 4/5 should not equals to -L/10. Right? So I can multiply both sides by 10, but here it's not an equal sign. But basically, if you multiply both sides by 10 like this, you will get L should not be equals to -8. What's the meaning of that? Except -8, for all the other L values, you will get one solution. Right? So basically, so many values, infinite L values. Except -8, all the other values are fine. For all the other L values, you can solve that system. That's the idea. Right. And also I want to mention one thing here for no solution case. Now clearly, if you compare C1 and C2, that is -1/5 and 4. Right? -1/5 and 4. These two values not equal. Right? Therefore, that's perfectly fine. But in some occasions, this can happen. M1 equals to M2, which means slopes equal like this. But then C1, if C1 also equals to C2, then we are talking about something interesting. Right? Same y-intercept, which means then we will get the same line like this. Same line, right? Because y-intercepts also equal. We can discuss that separately, but in this case, no worries, because C1 does not equals to C2. Therefore, there will be a gap between these two lines because of the difference of y-intercepts. That's the idea. So answer for this problem, this one. L does not equals to 8. So all the other values. Basically minus infinity to minus 8, minus 8 to plus infinity. But you can't put minus 8. Right. So that's the second problem. Let's move to the third one. So very similar idea. Yeah, this problem. Here we have a problem with infinitely many solutions. That's the third case. Now try to visualize this case. So we discussed about no solutions and one solution. In this case, infinitely many solutions, which means to get infinitely many intersection points, how would you draw the next line to get infinitely many solutions? I think something like this, top of each other. Same line basically. Yeah, because that's when you get that. That's when you get infinitely many solutions like this. So that, right? So basically, we are talking about the same line. We need same line in both occasions, because then we will get infinitely many intersection points. Basically, top of each other, I can't draw that. Otherwise, you won't be able to see. That's fine. Now, infinitely many solutions. For that, what should happen? We need the same slope, definitely, but that's not enough. That's not enough, because with same slope, you will get something like this. Then there will be a gap. Then that case, no solutions. But in this case, slope should equal slope of first line and slope of the second line. M1 should be equals to M2, and also more importantly, the y-intercepts. That's very important. Let's say C1, C2. There can't be a gap between C1 and C2. Hence, C1 should be equals to C2. Like those two. This is the requirement to get infinitely many intersection points, which means infinitely many solutions. So, what do we need? We need a H value such that M1 equals to M2 and C1 equals to C2. These two conditions should satisfy by that H value. You can't compute that by solving. You can't solve these equations because H is a constant and X and Y are variables. But to check this condition, we can create slope-intercept form for both lines, because then we can compare slopes and also y-intercepts. Right? So same concept, create slope-intercept form, y equals mx plus b. Let me start with first line. That's a line, right? So I can move minus x to the other side, 1x minus 6. Then divide both sides by 3. Divide separately. That minus 2, 6 over 3 minus 2. But in the next step, I'm going to put plus sign between these two terms. Then compare that with mx plus b. Then 1 over 3 is the slope and minus 2 is the y-intercept. Right? So let me express like this. M1 equals to 1 over 3 and B1 equals to minus 2. And why don't you apply Same concept for the second line to get M2 and C2. Don't worry about H. H is just a constant, right? Divide both terms separately by 6 minus 2. Plus minus 2, right? Then we can compare again, because here the aim is computing the y-intercept and the slope. So clearly M1 equals to H over 6, sorry, M2, and B2 equals to minus 2. Now here, previously I used C1, C2, same thing, right? Okay, let me use 3 here. Otherwise that can be confusing. C1, right? C2. What's the requirement? M1 should be equals to M2 and C1 should be equals to C2. Clearly, C1 equals to C2. Therefore, don't need to worry about that at all. But now we can compute H value such that M1 equals to M2. Okay. So for infinitely many solutions, M1 should be equals to M2. Hence 1 over 3 should be equals to H over 6. From that, you can get H. Multiply both sides by 6. H equals to 6 over 3, that is 2. So that for that H value, you will get infinitely many solutions. And interestingly, yeah, you can do something like this. So we know that for H equals 2, we should get infinitely many solutions. Okay, let's see. Now the first equation, this is the first equation. But if I replace H by 2, what will happen? The second equation, that is 6y minus 2x equals minus 2. Now, if you observe carefully, I think you can understand. Can you see that? If I divide this second equation now, the entire equation by 2, I'll get the first equation. I can divide any equation, both sides of an equation by any number, not by 0. Let me divide both sides of second equation by 2 to give you an idea about this process. Let me divide 2 by 2. So that is 3y minus x equals minus. That is basically the first equation, right? Essentially, we are talking about the same line. Equation 1 and equation 2 both represents the same line. That's why we got infinitely many solutions, right? Okay, maybe we can move to the next question, fourth question. Right? Very similar, right? To get infinitely many solutions, again, the same idea. Basically, whenever you have a problem like this, you can visualize the infinitely many solutions case, which is basically two lines top of each other. For that, the requirement is slopes should equal. Not only that, y-intercept should also equal. So that's the requirement. You can solve this system. No, don't need to solve this system. Just need to check these. Just need to compute C such that this condition is satisfied. So let me create the slope intercept form. I'm going to multiply the whole equation by 4 to eliminate that, to eliminate this 4. That's another way, which is moving x to the other side and like that. So let me expand this bracket. 4x minus 4 into 1 over 4y equals to 60. This is one way of solving this. One way of creating that form, slope intercept. Or you can move x to the other side initially. That way also you can solve. 4x equals minus 1y equals 60. I can move y to this side, 16 to the left hand side to create that form. That is basically 4x plus minus 16. I did not change anything. Basically the same equation, same line. Multiplying both sides by a constant won't change anything, right? And also the second line, this occasion I'm going to multiply both sides by 8 because that's the requirement to create the slope intercept form. Eight and 8 can cancel. You will get minus 1 by here equals to 60. Then I can move y to the other side. 8cx, that's the slope, 8c, you will see that. Then minus 16 y. HCX plus minus 16. Then you can compare these two equations with the slope intercept form, right? Y equals mx plus c. That can be a bit confusing because we have another c here. Let me use b, mx plus b, right? And here also mx plus b. So b1 equals to minus 16, b2 equals to minus 16. So basically we have the same y-intercept. Slopes, I think m1 equals to 4 and m2 equals to 8c. That's the most important part. Right? Can you visualize that? That minus 16 is the y-intercept, right? So both of these lines surely goes through this point, minus 16. Intersect y-axis at this point. Both of these lines. But I can draw so many lines. So m1 equals to 4, that line I can draw like this. Line with a positive slope. Then the next line definitely goes through this minus 16 point. But how many lines can I draw through that point? Can you understand? Can draw so many lines through this point. For example, if you consider a case like this, how many intersection points? Only one. But we need infinitely many solutions. You can't really change that pink line because fixed values. But of course, you can change the green line. To get infinitely many solutions, I think we need that green line like this, top of the pink line. For that, slope should equal to the slope of the pink line. Hence, M2 should equals to M1, right? So basically, M2 is 8C, M1 equals to 4. Divide both sides by 8, C equals to half. For that value, you will get a situation like this. But for one solution case, slopes should not equal like this, right? So there are so many values for that because you can draw so many situations with different slopes like this, like this. So for such cases, M1 should not equals to M2. So therefore, exactly one solution if this happens. What about no solutions? In this case, you can't get no solutions. Why? Because both of these lines should go through this point. So if both of those lines goes through that point, there must be at least one intersection point. Because definitely there will be an intersection point at that point. Right? Okay. In other words, for no solution case, we need different y-intercepts. Right? For no solutions, M1 definitely should equals to M2 like this. But the y-intercepts should not equal. Otherwise, you will get infinitely many solutions case. This is the requirement for no solutions. For one solution, here's the requirement. Doesn't really matter B1 and B2 for one solution case. But for infinitely many solutions, M1 should be equals to M2 and y-intercept should also equal. Basically same line, right? Because if the slope and y-intercept equals, we are talking about the same line, right? So these three cases, focus on these three cases. To solve these problems, you should create y equals mx plus b form. Right. I think that's enough for today. Thank you very much.